Hey everybody, it's been a few days since we've actually jumped into the probability unit here, so hope you're ready to go. We're going to go through the probability chapter review, and we are going to do 1 through 11, and then you are going to do 12 through 14. Now your worksheet does not say 12 through 14. That's because it's your job to create them, and it's your job to answer them. So we will get into that here in just a second, but for now, let's just review what we know about the first 2 lessons of the probability chapter. That would be permutations, combinations, and the fundamental counting principle. All right, so find the number of permutations. All right, now we have a formula for it if we want. I'm not a huge fan of the formula, but I think it's a good thing to present to people. And it's going to look something like that. Now, if you were to try to use this formula all the way through, you would get 7 factorial on top, and you would get 7 minus 3, which is 4 factorial on bottom. So if you were to lay this out, it would look really intimidating until you actually wrote it out. I think one of the reasons why people struggle with it is because they don't realize just how little work you're going to have to do. Instead of actually multiplying all these numbers together, what you could also do is just recognize, oh, wait a second, 4 divided by 4 cancels out, 3 divided by 3, 2 divided by 2, and 1 divided by 1, and so all you're really left with is 7 times 6 times 5, which is 210. Now that brings up the other way that I taught you. The other way that I taught you is just using blanks in general. You can start with the number 7, and then since you're choosing 3 items, as soon as you have chosen one of the items, now you only have 6 left to choose from, and then you have 5 left to choose from, and you stop there because you're choosing 3 things. That saves you from having to do the big long formula. All you have to remember is that the first number is your starting point, and the second number is how many blanks you have to actually draw. Okay? Personally, I think that's easier, but I know there are a lot of people who just prefer doing a formula and being done with it, and I get that. All right, number 2, I'm going to skip the formula for this one, and I'm only going to use the blanks. I'm going to say, well, there are 4 items that we're going to choose. We're going to arrange them in order, and we have 6 to choose from. So we have 6 choices for the first, 5 for the second, 4 for the third, and 3 for the fourth. If you did the formula, you would find out that it would all cancel out and reduce down to create this exact same scenario. Anyway, 6 times 5 is 30, times 4 is 120, times 3 is 360. All right, so no matter how you set it up, you're going to get the same answer. All right, number 3, in how many ways can 5 of 8 girls be arranged in a row for a beauty pageant? All right, so again, we're talking about an order. We're talking about an arrangement. So in this case, it would be a permutation. I also know it's a permutation because it's in the section that says find the number of permutations. Oh yeah. All right, so you have 8 girls who you can choose for the first spot, and then 7, and then 6, and then 5, and then 4. The formula would also give you the correct answer if you felt like it or not. All right, so what you're going to end up getting is, this is dangerous mental math in the morning by me. I'm going to go the other way around here. 5 times 4 is 20, times 6 is 120, times 7 is 840, times 8, that's 6,720 ways. Oh boy. Well, if that's not right, then I guess I'm going to have to redo the video later. All right, there you go, 6,720 ways. All right, now, combinations, in case you have forgotten in these 4 days, this is where order doesn't matter. So this is where I say, you know, if Bob and Chris are in a group of Bob and Chris is the same as a group of Chris and Bob. So you have to divide out the repeats because order doesn't actually matter. Okay, so in this case, you have 12 choices for your first person, you have 11 choices for your second, you have 10 choices for your third. However, because order doesn't matter, we have to divide out any groups that have the same members and are just repeats of each other. So that's where the division step comes in, the combination count up, if you will. So you end up getting 1320, but then you have to divide it by 6. So when it's all said and done, you end up getting 220. Now, number 5 I threw in there just to be annoying, if we're being completely honest here. Because if you were to choose 7 people out of a group of 7, let's be realistic here. Didn't you just choose them all? Because if you do the combination count up, then you're going to find out that you just had to count up all the way to 7 again. And if you count up all the way to 7, now you have the same exact thing on the numerator as the denominator, which means your answer is just 1, all that work, and you end up getting 1. Now, this came up earlier. I just want to bring this up here on the side. It is not on your paper, but I want you to think about it anyway. A problem like this came up earlier. Let's say you have 10 people applying for a job. Guess what? Sometimes they all stink. There is such thing as a 10C0. Basically, the real life scenario behind that would be, like I said, 10 people apply for a job, and you decide to choose none of them. Are you allowed? And the answer is yes, you are. There is a way to do it. Just send all 10 of them home. Anytime you are choosing 0 of something, there is one way of doing it. And that one way is literally just choosing none of them. All right, now that being said, we're not going to be negative here. We're going to be positive. We're going to talk about an employer selecting 4 new employees from a group of 10. So now we're going to set it up like this, and there is going to be a combination count up, because it's not like we are ranking the employees in this. So that's something for you to keep in mind when you write your own problems. If order matters, if you're talking about, you know, the example that we always seem to use is like a student senate kind of thing, where there is a president, there is a vice president, and all that. Order does matter. In a country, the order matters. But if we're just talking about, hey, we're going to take a group of these people and we're going to choose them for one type of job or something like that, then that's when order does not matter. Anyway, so once again, we're going to do the dangerous mental math here. We're going to multiply the top without a calculator. Look out, world. We are going to multiply the bottom without a calculator. Once again, look out, world, and we're going to get 210 ways. Which is, interestingly enough, the same as the answer to problem number 1. All right, let's do a few more here. This time around, you're not going to be told what type of category it is. You have to choose it. So number 7, on a test, a student is to select any 6 from a group of 10 to answer. In how many ways can the student do this? So you have 6 out of a group of 10. That sounds like a combination. The reason being, I can't tell you which order to do them in. I'm just saying, hey, you've got 10 questions in the group and you have to choose 6 of them. All right, now, again, there is a formula for it. I usually just set it up using blanks myself just because I think it's easier that way. So we are going to make a mess of this because it's a pretty big problem. And this is actually a great segue to something that I brought up yesterday. It was actually option number 3 for your writing prompt yesterday. A few people did it. So 5 divided by 5 and 6 divided by 6 are just 1. They cancel out. Which then brings up an interesting point. Take a look at the setup for number 6 and take a look at the setup for number 7. So problem number 6 was a 10C4 because we had 10 applicants and we were choosing 4 of them. Question number 7 is a 10C6, and if you look, the math ended up being the exact same problem. So the question is why? Why is it that a 10C4 and a 10C6 are exactly the same situation? Well, here's why. If you choose 4, there will be 6 left over. If you choose 6, there will be 4 left over. So when you are doing a combination of choosing 4, where there are 6 left over, and doing a combination of choosing 6 and having 4 left over, no matter how you break it up, aren't you making a group of 4 and a group of 6? That's why the answer always comes out the same. So to bring up a wild example, and this was the one that I did yesterday, if you had a 50C48, that sounds really intimidating. Even the calculator takes a second to do it if you're trying to figure out what's going on. But if you're choosing 48, you're going to have 2 left over, which means a 50C48 is really the same as a 50C2. So essentially, having a combination where you have 50 items and you choose 48 is the same idea as having a combination of 50 items where you're choosing 2. So that means this right here and this right here will both have the same answer. Okay. So that's a pretty cool thing. It works for combinations. It does not work for permutations. All right, number 8. In how many ways can a group of 3 students be selected from 15 to take part in an anatomy class? So once again, this is going to be a combination. It's going to be a 15C3. The reason being, they didn't rank the students. They just said, hey, we're going to have an advanced anatomy class, and we're going to pick 3 of you to get, I don't know, promoted, it almost seems like here, into the advanced class. All right, so 15 times 14 times 13. You can break that out on a calculator. Once again, I'm going to live dangerously, and I'm going to try to do the math in my head. Like I said, I'm going to find out that I'm wrong on one of these, and I'm going to have to redo the whole video. That's going to be annoying. All right, that's fine. We have 2730 divided by 6, which should be 455 ways. Now I'm going to tell you what, number 9, I am not doing mental math for that one. There are 19 students in a sorority. How many ways can president, vice president, and treasurer be chosen? The reason I'm not going to do this math mentally is because the number is going to end up being really, really, really big. Order matters. When we're talking about president, the order matters, which means we have to just multiply through. There's no division. There's no combination count up. There's nothing like that. You're going to multiply and you're going to be done, and you're going to end up with a really big number. So that means we are going to actually bring the calculator in, which I probably should have done a long time ago, but that's okay. 19 times 18 times 17 would be 5,814 ways that you could choose those people. Now, obviously, in real life, not everyone is going to want to be vice president or treasurer, but in this case, that is the answer to the question. All right, number 10. The pizza place has 6 different types of topping. 1, 2, 3, 4, 5, 6. How many different kinds of pizzas can be made using any 3 of the toppings? So if you call in and you say, hey, I would like a pizza with mushroom and pepperoni and sausage. That sounds delicious, actually. You're going to get the same pizza as if you called in and said, I want a sausage and pepperoni and mushroom pizza. Order doesn't matter in how you request the toppings. You're going to get the same pizza. So it is going to be a 6C3. Now, I'll tell you what. It seems like every year I end up with a student. Usually it's only one, but they say, well, I actually work at a pizza place, and you have to put the green pepper on last or else it'll burn. Or, different things. And I usually just have to tell that particular student to shut up, if we're being honest, because we don't know that. We're just doing a math problem in our class, and it's not really like that, but that's okay. I know there are tricks to the trade that sometimes don't come out when you're doing a word problem, but that's okay. So how many different kinds of pizzas can be made using any 3 of the toppings? I did a combination count up. Because, again, to me, order doesn't matter. When I'm calling in the pizza, order doesn't matter. I'll let the worker decide which topping he wants to put on first. All right, we got 20 ways. Now, this last problem, number 11, it seems like it's going to be kind of a tough one, and then you realize it's actually an example of the fundamental counting principle. Okay? So let's review here real quick just to make sure we know what's going on. Whenever you see a group problem, it's an example of combinations. Whenever you see president, vice president, that sort of thing, and I want you to write this on your paper because I told you to anyway, that's an example of permutations. Number 10, again, it doesn't matter what order you select the toppings in. Now, number 11, the reason I want you to think of this as something different. This is an example of the fundamental counting principle. I don't want to make anyone feel insecure here, but I may or I may not be tutoring a 4th grader who is learning this. Just want to throw that out there. If you have 6 different appetizers, 8 different entrees, and 5 different desserts, and you want to do the discount offer where you choose one of each, how many ways can you choose your meal? Whenever you're doing the fundamental counting principle, all you have to do is take your options for each category and multiply them. The number doesn't go down every time or anything like that because your choice of appetizer doesn't affect your choice of entree. It's not like, oh, you got the mozzarella sticks, that means you are not allowed to get the Cajun chicken pasta. That would be a very strange restaurant. I don't think they would be a restaurant for very long. But if you just multiply everything together, you end up finding out there are 240 ways that you can choose your meal. All right, so real quick, I just want to make sure you remember my request from you. You have a little bit of space on your paper. If you don't have enough room, then do it on a separate sheet and scan that as well. 12 through 14, you are going to create your own. It's going to be one of each type. It's going to be one permutation, one combination, and one fundamental counting principle word problem. I want you to create your own and then answer them. Don't just create it. I want you to answer it too. Don't go word for word with the problems that are here. If you're having trouble and you need to sort of just vary them a little bit, that's okay. But I want you to be thinking on your toes. All right. I hope this helps get you a little jump start here on math for the week. We're going to do the rest of the chapter review tomorrow, and then we will wrap up the chapter. Thanks for watching. I'll see you next time.